Hello students, today our topic of discussion is heat transfer. So like we know that heat is a kind of energy and energy is transferred from one object to another or from one point to another. The process of transferring of heat from one point from A to B is called heat transfer. Now we have three methods of transfer of heat. We have three methods of heat transfer. Number one is conduction, number two is convection, and number three is radiation. Now what is conduction? So in conduction process, the molecules of the material does not move at all. This conduction type of heat transfer is totally based on the principle of calorimeter. When one molecule is heated which is near the heating region, then the adjacent molecule will also get heated because of the change in the temperature or because of the difference in temperature between the two molecules. So after some time, as a result, after some time, heat is transferred from molecule to molecule and reach the other end of the object. Now in conduction type of heat transfer, this amount of heat get transferred from one end to another is dependent in four variables. Number one, H is directly proportional with A. Number two, H is directly proportional with temperature difference delta T. H is directly proportional with respect to time small t, and H is inversely proportional with the thickness of the object. So while combining these two equations, we get that H, the amount of heat conducted from one end to another end of an object, is directly proportional with A delta T into small t by x. So H is equal to some constant K A delta T into small t by x. Now that constant K is called coefficient of thermal conduction, or it is also mentioned as thermal conductivity. So what is K? K will become H into x by delta T into small t into capital A. So a unit of K will become joule per meter Kelvin second. This is the SI unit, whereas in case of CGS, the unit will be calorie per centimeter degree Celsius second. So this is your amount of heat conducted from one end to another end. We know, so heat is a kind of energy. So power will be energy by time, H by T. So power will be Ka delta T by x. Now our second method of heat transfer is our convection type of heat transfer. Now in this case, in convection type of heat transfer, the molecules itself moved from one place to another while carrying the heat. So due to the movement of the molecules, a flow of the liquid or flow of the substance, flow of molecules occurs, which is called convection current. Example is breeze and ocean current. Ocean current is produced due to that convection current or convection type of heat transfer. So while heating, the molecules become lighter in weight and uprises, whereas the polar molecules are heavy and they are become down. So as a result, a movement of molecules occurs. While boiling a water, that much of that movement of the molecules of water is called convection current. Now that convection type of heat transfer, it depends on the area of the substance or surface, delta T, temperature difference, and time t. So Q is proportional with area, Q is proportional to delta t, Q is proportional to small t time. So Q will be a constant H into A delta t small t. That constant H is called convective heat transfer coefficient. Now last method of heat transfer is our radiation heat transfer. So radiation is the radiated heat is nothing but an electromagnetic wave. A radiated heat is nothing but an electromagnetic wave. Radiation is the process by means the heat from sun comes to other planets or our earth. So in electromagnetic wave, we know that amount of energy is transferred as a packet, as a form of a packet, and that much amount of energy is fixed quantity, and that much amount of energy is given by some constant H into nu. Nu is the wavelength of the light radiated. Okay, so E is equal to H nu. Now in case of radiation heat transfer, the amount of heat transferred from one place to another in vacuum. So in radiation type of heat transfer, it does not need any molecules or any medium. So radiation type of heat transfer occurs in vacuum. So the amount of radiated heat Q is equal to sigma epsilon A delta T to the power 4 into time. So that sigma is a constant called Stefan-Boltzmann constant, and epsilon is another constant which depends on the material of the object, which is called emissivity of the object. Now what is emissivity? Emissivity is the ratio of the radiation of the object to the radiation of the black body, whereas T, temperature, remains constant. Now what is black body? So black body is a body or an object with perfect emitter capacity. That means black body is an object whose emitting capacity or absorbing capacity is perfect. That means black body is a perfect emitter or perfect absorber. That means that whenever you supply certain quantity heat to a black body, it will absorb the total amount of heat, 100% of the heat. Next, another term related to radiation is absorptivity. This is fractional radiation absorbed by anybody. Reflectivity, fractional radiation reflect by certain bodies. Transmittivity, fractional radiation transmitted or transferred from one object to another object. And last one is radiosity, that is reflected plus emitted radiation together are called radiosity. So when an incident amount of heat falls on certain object, this is the object, so these things occur. Some portion or fraction gets reflected, which is called reflectivity of the object. Some portion is absorbed, that portion or fraction is called absorptivity of the object. Some portion is transmitted if this object is what? If this object is not opaque. This is a what object? This is an transparent object. Transparent object. So if this is a transparent object, then some quantity or amount of heat will be transmitted. That much amount or fractional quantity of heat transmitted is called transmittivity of the object, and some portion is emitted among the absorption portion. So some portion is absorbed and some portion, when the body will be heated, some portion is emitted, some portion of heat is emitted from the body, which is called emissivity of the body. So these are the important terms related with radiation, and the radiation heat is given by this much. Q is equal to sigma epsilon 0 A delta T to the power 4, that is temperature difference to the power 4. It's a huge quantity, and into small t. T is the time of the radiated heat transfer.